Swayam Prabha. Digital India. Educated India.
This is the very first lecture on statistics. I would like to introduce the subject to all of you. The question that comes to our mind, why at all we want to study statistics? What is the importance of statistics in engineering or in technology? The first point, which is very important, is that statistics deals with collection, processing, analysis, and interpretation of numerical data. So if you read them very carefully, that there are quite a few steps which are involved in getting the data. We have to collect the data that we get by doing some experiments or by measuring certain properties or by observing certain phenomena, whatever it is. The first and foremost is to collect somehow data. These data are numerical data. If some data are not numerical due to some reasons, we have to convert them into numerical data. Once the data is there, we call it a raw data. So this data sometimes we need to refine because there are techniques to find out whether some data that we have collected is rogue data or not. So sometimes we need to therefore refine the data that we collect. Then comes the processing of the right data. That is, after refinement, the data that we have with us, we need to process it. There are many ways to process the data which you are going to learn. So processing is followed by analysis. We want to analyze the data from different perspectives. And once the analysis is done, what is left is interpretation. We have to interpret it. Statistics is not going to interpret. The interpretation of the numerical data is also very important. So the sequence is collection, processing, analysis, and interpretation. Once we have done this interpretation, it is going to help us in taking objective decisions. Ultimately, statistics is a tool to make some objective decisions. Decisions are not based on subjectivity. There is a mathematical background behind taking these decisions. So there is a logic, and based on that logic, whatever decision we take, that decision will be very objective in nature. Next is statistics is a very vital tool for engineers, therefore. And there are statisticians also. They also use statistics. Agricultural scientists, agricultural engineers they also use statistics. Management people can also use statistics. So statistics is a kind of tool which is used by many or people belonging to different professions. Engineers also need to use this statistics because it helps to understand a phenomena which is subject to variations and effectively predict and control them. This is very important because there are certain phenomena which we want to understand. So before we make a conclusion, we need to know whatever we are observing, is it correct or not? Whether the data that is coming to us from the data, our understanding about a particular phenomena, is it correct or not? So there has to be some kind of objective decision making, and statistics is used as a tool for engineers to predict sometimes or to control a phenomena. So statistics is the science of problem solving in the presence of variability. Variability will be always there, and it is a part of nature. So most of the natural products are variable, and in an industrial process also there is a lot of variability could be there. Though we want to bring down the variability by taking appropriate measures in terms of having a lot of controls that is with us, but even then there's always a chance of variations, and you will come to know as you go through the course what are the different sources of variability. Some of these variabilities almost beyond our control, and some variabilities are within our control. So whatever is within our control, we take measures to counter them, and we want to reduce the variability. That is all you are going to learn in this course. Now the next point is we'll discuss the importance of statistics by giving some examples so that it becomes very clear in your mind. Let us say a manufacturer has to mark size of the garment according to the chest girth of men. So you have to produce some garment, and the garment size should be according to the chest girth. Therefore, the manufacturer needs to know what is the average chest girth of the population he is going to solve. This question comes to their mind. So if this question comes, what we are supposed to do? We have to find out average exactly. One needs to measure all the men in the population. If we want to know the average value exactly, then one needs to measure all the men in the populations that we have. Otherwise, we will not be able to find out what is the exact value of average. However, this is an enormous task. If the population is huge, it will go into millions. Then it will also involve a lot of cost, money, and time. And therefore, it is almost impracticable that we will try to measure the chest girth of the entire populations. This is something which is not possible. So alternative is to measure the chest girth of few thousands, let us say, taken at random. And this is called the sample. That if the population size goes into millions, we only take or measure the chest girth of few thousand people. So that few thousand people becomes a sample. And the average chest girth of that sample now can be easily found out. So once we know the average chest girth of this sample, the manufacturer wants to know from this, how do I find out the chest girth of the entire population? So the question remains, entire population cannot be measured. Only a sample of certain size can be taken, and we can measure and find out the average value of that sample. Therefore, the problem can be stated as, from the sample data, what can be said about the average value of the populations? That becomes a very, very important statement. From the sample data, what can be said about the average value of the populations? How can I say about the population based on sample data? That is something we need to know, and there is a way to say something about the population using statistical methods. That's what will be important. That's why we need to have some idea about the statistics and its principles and how we can use it. So this is a typical industrial problem. The another problem example is, suppose a weaver buys yarn from a spinning mill. He is a weaver, he could be knitter, whatever it is. The yarn tenacity of each batch received should have an average how much? Between 18 plus minus 1 gram per text. That should be the tenacity of the yarn. Because the kind of loom that he has, the weaver knows that as long as the average lies in this range, 18 plus minus 1 gram per text, the loom efficiency is quite good and he remains satisfied with that. Question therefore comes, once a particular batch of cone, suppose it arrives in the mill, the weaver, how the knitter or weaver, it could be knitter or it could be weaver also, will decide whether or not the average linear density of the batch, but not linear density, the average tenacity of the batch is 18 plus minus 1 gram per text or not. That is how he will know. Now, to find the answer to this particular question, one way is to test the entire batch. But testing the entire batch is impracticable, since testing of strength is destructive in nature. Therefore, if all the yarn is tested, there will be nothing left now. So that's a real problem. If it is a destructive test, then if entire batch is tested, all the yarns will be spoiled, will not be able to use it. So the weaver will test a small sample of the entire batch. Now the two questions will arise in his mind. Suppose he decides that only a small sample is going to test. The two questions that comes to our mind, how many tests to be performed? How many tests to be performed? That question comes. And how the test results to be used to find out whether or not the yarn meets the agreed specifications or not. Because the data that you will generate is the average strength of the sample that you are going to choose. From that sample data, how do I predict or how do I estimate the strength of the yarn in the population? So that sort of, this is another type of problems that arise in our mind when we are working in the industry or any organizations. And we'll see that such kind of problem can be tackled with the help of statistics. Then we'll discuss about few terms. First of all, populations. Statistical population consists of all possible items or units possessing one or more common characteristics under specified experimental or observed conditions. That is what the population would mean. Therefore, in the example 1 that we have discussed, the population is the human. Chest guards. We wanted to know what is the chest guards of the people for whom the garment will be made. So, in this case, the population is the entire human being that we have in that particular country. If it is chest guards of the male, so chest guards of the male population. Or if it is female, then it is female population. That becomes the population. For the second case, the population is the delivery of the yarn in a batch. The entire batch that is just being delivered, that becomes my population. So in a batch, if it is maybe it may having 2, 3, 4, 5, 10 trucks load of suppose cones or cheeses which are coming. So many tons of material will be populations. So entire batch is going to be the population. The entire delivered yarn is the population now. So that is what population basically means. Now sample is what? As we have said, that it is impossible to examine each member of the populations. So the question regarding the population has to be answered by examining only few members. All the members cannot be taken into consideration in the measurement. If it is whatever it is, we cannot go to each and every member and try to measure them. Or if it is cones or cheeses, the entire set of cheeses that we have, we cannot be really not be able to find out strength of the yarn that is there in these cones or cheeses. And hence a sample basically is consisting of few members. A sample is therefore a group of observations taken from a population. It's only a group of observations taken from a population or from a process. If there is a process, suppose it's a production process, a machines are running, it is producing something. So from there, the machines are continuously running for 24 hours. So we take samples from the process. That means we will take few members representing the populations. So few members, or if it is a data I am collecting from the suppose process, then a group of observations will be my sample. Then comes another important term called variations. So what is variations? All natural things and man-made things will invariably vary in their characteristics. There is nothing which is not going to vary. You take any object from the nature, there is a variation in size, shape, or color, whatever it is, it will vary. Their numbers are not, size are not fixed, whatever it is. So nature is producing things where it is definitely varying in its characteristics. Similarly, whatever we produce using our machines or process, there will be always some variations in the characteristics of the output that we get from the process. So variation is an inherent characteristics of products made by nature or products made by a manufacturing process. Statistics is all about trying to say something about the population when only results of a sample is known. So we don't know about the entire population. Only from the sample, we have to say something about the populations. That is all about statistics will be dealing with this only. Then variable. A property or a characteristics on which information is gathered in an experiment is a variable. In statistics, we deal with quantities that vary, and such quantities are called variables. Now, if we look at the example of variables, now it could be weight of consecutive length of a fabric. Suppose I have a fabric roll and I cut the fabric roll, which could be 100 meters. I cut 1 meter length consecutively and then measure the weight of this fabric. What we will find? The weight, the value of this weight is not constant. You will get different figures. So weight becomes a variable in this case. So weight of unit length of fabric is a variable. Similarly, number of folds in a given length of yarn. So if we count the number of folds in a suppose 1000 meter of yarn, we keep counting, then first 1000 meter, then another 1000 meter, then another 1000 meter. And if we record this data, then we will find that the values which are coming, the numbers that I am generating, they are not same. So therefore, number of folds in a given length of yarn, that becomes my variable. So all variables have a number associated with them known as values of the variable. So if weight is represented by W, then W is a variable and the value of the variable is what is the, if it is 150 gram, 151 gram, then these become the values of W. So something that varies is basically a variable. Then types of variable. Now variables could be three different types. One is discrete variable, continuous variable. Another one is the variable based on subjective assessment. Now we'll discuss what are the discrete variables, what are continuous variable. By counting the number of times an event occurs, the value is always a whole number or an integer. Suppose I count the number of times an event occurred. So number of folds in a given length of yarn or number of folds in a given length of fabric. You will always get some whole number. It will never come in fraction or in decimal figures. Number of phone calls coming in a booth in 5 minutes time. If you keep counting them, the numbers that you will generate will be always some whole number, that is, they will be always integer. They cannot be negative numbers. It could be 0 or it could be 1, 2, 3, 4, 5, whatever it is. So these are known as discrete variables. So as I said, number of falls, number of absentees in a class per day. That also if I record how many students are absent in the class. I keep a record for 30 consecutive days. we'll find this figure is varying. But the figures will be always in integer. So that is, these are known as discrete variable. The other variable is continuous variable, what we get by measuring using an instrument. Example, strength of fiber or weight of people or height of people. So if I want to measure the strength of the fiber, you'll get a value which could be, if it is fiber, suppose you get it 3 gram per denier, or if it is don't express in tenacity, then it could be 10 gram, it could be 6 gram, it could be 11 gram, something like this. These values you will get. It could be 11.2 also, it could be 10.8 also. See here, the variable is continuous. It's not that it has to be an integer. We can get decimal figures also. Similarly, weight of people, height of people, all possible values, decimal figures are possible here. And hence, these are known as continuous variable. Now, there is another set of variable which we get through subjective assessment, because there are certain properties which cannot be measured or cannot be quantified by simple number. What are those? Handle of a fabric, look of a garment, whether the garment is looking good or bad or not so good, we cannot measure the appearance by any instrument. So there are certain, you can say, characteristics which are not measurable by using the instruments that we have with us. Similarly, handle, though handle we are trying to measure it using lot of different properties of the fabric, but still handle is something which people get by feeling or by touching a fabric and squeezing the fabric between the fingers. The kind of sensation that we get, that is what is called the handle. It is something which is so complex in nature that instrumental evaluation is not a true representative of the actual handle value of a fabric. So in these cases, what we do, they are subjectively assessed by expert, and the experts will give some rank, and these ranks are then maybe converted into numbers. So this is the technique that we follow. So this could be another type of variable which is neither discrete nor continuous, but they are subjectively assessed and ranks are given. Rank number 1, rank number 2, rank number 3, like that we give. Or A grade, B grade, C grade, what we say is basically a kind of ranking of some property. We say it is A grade material, or it is B grade material, it is C grade material. So they are basically subjectively assessed, and then we can think of converting this subjective assessment into some numbers. Okay. Next, random variations. This word will be coming many times during statistics. Random variable, it is random in nature, random sampling. Therefore, what is random variations? See, variations can be intentionally introduced also. That is not random. Like we produce slab yarns where the linear density of the yarn is varied in a systematic manner with the help of the machine by changing the speed of the drafting rollers. We create slabs. So it is a variation which is intentionally introduced. So it is not a random variations. This is called systematic variations. Randoms or chance source of variation, like say variation in the properties of the yarn along its length due to variation in fiber properties, temperature fluctuations, drafting rollers mechanical defect, or etc., or maybe due to innumerable factors which may come and affect the variation in some properties of the yarn. It could be the say mass per unit length variations of a yarn. It could be the strength variation of the yarn. It could be modulus variation of the yarn. It could be breaking energy variations or whatever now comes to the mind, mechanical properties that comes to the mind. They are all, we'll all find that there is a variation in them, and this variation is because of multiple reasons. And one of the reasons is variation existing in the material itself, that input material. Cotton fiber is variable. It varies in terms of length, fineness, strength, and therefore the raw material itself varies. The yarn also will vary. But the yarn is ultimately a collection of raw material. Similarly, the processing disturbance could be there always. So all these variations which is there in the process or the raw material can also could lead to a variation in the final product. This is what is known as random variations or chance source of variations. Such variations are usually outside the control. Generally, they are difficult to control. But we can find out that whether part of those variations can be controlled or not. The variables that are affected by random sources of variations are known as random variables because the sources of variation is also random in nature. The values of random variables occurs unpredictably, but still there is a pattern that can be observed. This statement is very important, that the values of random variable occur unpredictably, but there is a pattern that can be observed. And statistics will try to find out that pattern in it. Because if the pattern can be identified, from there we can make some projections. So exact values of the random variable can vary in unpredictable manner, but then collecting all those data, we can still find out some pattern in it. And statistics helps in identifying that pattern. Because once the pattern is known, from the pattern we can predict something. Existing of such pattern helps us to make meaningful statement about the populations. This is also important. So we'll try to identify the pattern, and from the pattern itself then we can make some useful or meaningful statement about the population. So these are basically your random variations. The more you go through the course, the more you will understand about this random variables and the variation associated with it. After this, we come to this part, that is data and their visualizations. As we said earlier, that statistics deals with data, and therefore, so data collection or gathering of data is also a part of statistics, so that the collection process should be fault free. And once the data has been collected, our job is then to visualize the data. What the data is going to reflect. If I have a big table full of data, we will not be able to really make out what this data is trying to say, or can we really extract some useful information from the data. Here just a small example of it, where we are actually showing you data related to breakage frequency, that is breaks per hour on a spinning machine. A spinning machine could be a ring spinning machine, rotor spinning machine, friction spinning machine, or airjet, or it could be fiber spinning machine, any machine, spinning machine. We know that there is or sometimes there is a discontinuity in the production process. So that means there is a break. Whenever there is a break, there is discontinuity, and this is something we do not want. But at the same time, the breakage cannot be avoided. At any point of time, there is a possibility of some breakage. Now here, the breakage data has been taken on a spinning machine hour-wise. That is, first hour, second hour, third hour, fourth hour, fifth hour, like we have gone up to 60th hour. And each and every hour, suppose the person is noting down how many ends have broken. That data is shown here, which is breakage rate, basically means breaks per hour. Every hour, how many breaks are there. Like in this case, very first hour, there is no break, so the value is 0. In the second hour, 2 breaks are observed, the value is 2. In the third hour, 5 breaks are observed, so we write 5. So like that, the data is collected over a period of 60 hours. And from this data, this data may be recorded of a process, and then from this data, as an engineer, one has to find out some meaningful observation, and from those observations, if we have, then probably we can take some corrective actions to reduce the breakage value. So that sort of possibilities exist. But first of all, if this data is given in front of you, how do I visualize this data? This is a small table, but you can have sometimes very large number of data. That could be thousands of data. It's possible. Then first thing that comes to the mind is visualizations. Visualization is very effective tool that conveys what is there hidden within this data set. So first what we do is frequency distribution of the data. First we convert this data into a frequency distribution. We have seen there that the number of breaks per hour, the minimum value is 0 and the maximum value is 6. So we write 0, 1, 2, 3, 4, 5, 6, and then we find out how many times or how many hours we found there was no breakage. That value is 15. Out of those 60 hours that was spent to collect data, 15 times there was no breakage, 12 times there was only 1 breakage, 11 times there was 2 breakage, 7 times 3 breakage, 4 times 8 breakage, 5 times 5 breakage, 6 times 2 breakage. So 6 breaks per hour happened only twice. That means higher number of breakages are not really many. Most of the time the breakage is limited to 1 and 2. That is one conclusion we can draw by studying this table. But before that we need to change the raw data into a frequency distribution table. But this is still not a visualization, it's still a numbers. Visualization means we have to convert this into graphs or charts. Then only we say that we are trying to visualize the data. So next point is that from the same data, the data have been plotted as a function of time, and this side it is number of break, that is frequency. So in the first hour, if you look at that data, you'll find there is a 0 breakage. So 0 is here. So on the x-axis 0, frequency is 0. In the next hour there were probably 2 breakages, so the value comes here. In the third hour we found 5 breakages, so we give these points and then join them together. So like that, the data points have been plotted in a chronological manner. And when you plot data points in a chronological manner as a function of time in this case, then the graph that we generate is known as time series presentation of data. So you get a curve like, a graph something like this, going up and down, up and down, up and down. So many a time such kinds of presentation is required because we may see some pattern in the data point that we have plotted. There may be periodic variation as a function of time in the breaks per hour. Maybe breaks is more, either maybe suppose in the evening breaks are more, or maybe in the midday time the breaks are more. Something may happen, then we can relate that what happens during this time the breaks have gone up, or sometimes the breaks are less, because the machines are same, the process is same, nothing has been changed. But still some kind of pattern sometimes we can find out in the breakage frequency. As these patterns then can be analyzed to find out what is the reason. The next one is frequency polygon and bar chart. So frequency polygon is same frequency. On the frequency table we plot, take the data and then plot this. These are the points representing, these are the breaks per hour, 0, 1, 2, 3, 4, 5, 6, and these are the corresponding frequencies, and we join them by a line. That is what is known as frequency polygon. So you can see there is a trend, and the trend say obviously immediately it brings to our notice that higher number of breaks are less in number. The next one is bar chart. We can also plot this in the form of a bar chart, where these are the breaks, 0 breaks, 1 breaks, 2 breaks, and the height of the bar represents the frequency. So 0 breaks are maximum, there are 15 in numbers, so therefore corresponding bar height is also maximum. Next was one break, then was third break, like that, second break, third break. So this is how the bar chart is made, and this gives us a pictorial representations of the breakage rate. So it quickly conveys what is happening. No need to look at the original data set. If the same data is plotted in the form of a bar chart, then it becomes very fast to understand what is going on there. So these are the ways that we can visualize that. There are only more ways that you will come to know gradually. The other thing is that, see, look at these previous data are all basically discrete data sets, because the number of breaks per hour is going to be either 0, 1, 2, 3, 4, 5, 6. It cannot be 5.2 or cannot be 2.8. It's not possible. Breaks can be only an integer numbers. So this presentation of data is for integer variables. And we can also have data set like height of students. The data values are given here. And we have here 50 data. So 50 students, their heights are measured and the values are given in this table. Then we can, this table has to be then modified in order to derive some meaningful, the meaningful information out of it. Otherwise, just by this table, you will not be able to find out really who is the tallest person. This you can find out who is the tallest person but then you have to search all the data. But if we take this data and convert them into frequency distribution, so what we see here, the same data we are representing in the form of a frequency distribution. So here is the table. Now what we find here, how do I generate this? Now we have to find out what is the lowest value, 161.3, and what is the largest value, 171.7 in this case. And we have 50 sets of data, 50 data points. So what we decide that whenever you want to make a frequency distribution table, first thing, the number of, that means we have to group the data. So we'll make class intervals. That, and within that class interval, we'll count how many heights in this case are falling. How many students have a height falling between these two limits? We'll put an upper limit and we'll put a lower limit. And we'll count how many students' height is falling within this limit. And that number will write. So first of all, we have to make groups. So we have to make a groups, we have to have a class intervals. So you say this is my lower class interval, this is the upper class interval. Lower limit and upper limit. And generally when we generate certain tables, we usually frequency distribution tables should have at least 5 to 7 classes. In this case, we have 1, 2, 3, 4, 5, 6 classes. We can have 7 classes, 8 classes. It's always good to have at least 5 classes, but not, I mean, at the same time, not too many classes, not 10 classes also. So how many classes one should have? The best thing is it should be varying between 5 to 7. Neither too many, not too less. So typically we keep it between 5 to 7. And then we find out what should be my lower limit and what should be the upper limit of the first class interval, second, third, fourth, fifth, sixth. So the lower limit should be set in such a way that the lowest figure gets included in it. So it will be slightly less than 161.3. So we put a value 161 here. And if the highest value is 171.7, the highest value would be, let us say, it could be 172. We could have done it 172. So what has been done in this case? The choice lies with the statistician who is working with this. That the class interval should be always, in this case, it is close to 1.9. So we are keeping 161, 162.9, 163, 164.9, 165, 166.9. So you see the difference between lower and upper is always 1.9, and we are reaching a value 172.9. So the entire data set, what we have, we wanted to include all the data, and from the based on the lower limit and the lower value or lowest value and the highest value, we have to decide what should be my limits of the classes, so that I can have 5 to 7 classes. Here, by keeping it 1.9, we could have 6 classes. Now if somebody makes it 161 to, let us say, 160 to 163, or 162.9, that also will be acceptable. And then these are the frequencies. So we have, once we decide about this lower upper limit, we count from here the how many students height is falling between 161 to 162.9, and the number is 3. How many are falling between 165 and 166.9? The value is 14. So like that, we keep on counting from here and place this value here, and we get a table which is known as frequency distribution table. So for different class intervals, the corresponding frequencies are shown here, and these are the midpoints of the class intervals. These midpoints and the frequency, these two can be used to find out the average value. That's why the midpoint data has been shown here, because this will be used. We want to know what is the average height. One way to find out that, you all the values that is given in this table, you take all these values and find out what is the sum and divide it by number of people, you can find out the average. That is also one way of doing the average value. Or if there is a frequency table given and we want to know the average in this case, then this is what is required. That is, we have to find out what are the midpoints of the class intervals, and the frequencies are given. Now using these two data, we can find out what is the average height of students. But this frequency distribution table helps us to get one important information, that this is the group 165 to 166.9. Most of the students are there, where 14 students are in the group of 165 to 166.9. Very tall students, 171 to 172.9, are only 4. And very relatively shorter height students, 161 to 162.9, also very less, that's only 3, only 4. So like that, now converting a raw data into frequency distribution data also gives us some additional informations. And now we can also plot this to generate what is known as histogram. So this data set, frequency distribution table that we get here, this table can be used, data from this table can be used to plot a kind of bar chart, which we call in the case of continuous variable as histogram. So histogram is a word to be used, is kind of bar chart only, but the bars are basically joined together, you can say. There is no gap between the bars. Unfortunately, that diagram is not with me just now, but one can easily plot using this data on Excel sheet. If you are quite proficient with Excel, use some data and plot histogram. Histogram is something which is used again for visualization of data, and is for using for continuous variable we use it. So that's all about today's initial very first lecture on this statistics, and as we go through the course you will learn more and more. Thank you.